So you can convert it into PDF if you want.
No problem. This. Wait.
Or you can convert it to PDF.
The PDF
Yes, yes.
is bad.
Yes, you can convert to PDF. I'm sorry. Forget to convert it.
It's better for this.
This is already.
No problem.
Yeah.
PDF. Okay, save. Wait. Okay.
So where's the?
Present the global range either Markov model for all bearing simulation analysis. So 15 minutes and have a question.
Okay, good afternoon. Thank you for coming today. So I'll start work about my research, my doctorate. So this research is supervised by my three supervisors that come from three universities, Mark, Pascal, and Fredericks. So I'm using the dual partition Markov model for detecting the degradations, diagnostic, prognostic, and decision for the bearing. So I start with the outline. We start with the introduction about the bearing, why we use the bearing, why it's so important in our daily life. And instead of the art, I'm going to show about the pseudo-cyclus merit. And for the case study, in this case, I'm using the simulation data. Even in reality, I have the real data. I will show my methods with the hit Markov model with combination for the generalized envelope signal. And we'll show the results. And we calculate the conclusions and perspective. So why I choose the bearing? Because in our daily life, we are using bearing. Normally, for example, we are using the vehicle or motorcycle, car. Inside of the machine, we have a small, very good operations. Sorry. So we have a small parts called bearing. It's very small. Even in the mining process, we have to use bearing with different form and different functions, and it's this small part will affect it the whole process of the industrial, because when a small part have degradations will be affected to the maintenance activity. And because I'm using the industrial process, I'm going to show about the predictive and condition-based maintenance. It's a combination of prognosis health management. So we have four main parts of cycles: data acquisition, diagnostic, prognostic, and also decisions. Okay. Okay, I start with the bearing. Why it's so important? Because about 50% of the missing failures come from the bearing. And if you want to know what's inside of the machines, we can open the machine, but it's not it's impossible, because we cannot open the machines of our car or into the other vehicles. So we use sensor to detect the vibrations. Normally, we are using the vibration sensor. Meanwhile, other authors use acoustic or any sensor like the thermocouple. And for now, about the bearing, we can divide it into 5 parts. We have the inner, we have the outer, also the ball of the bearing, and also the gauge. And each part of the bearing will produce a unique frequency. So when we have a defect in the inner, we can produce a signal to the different parts. Normally, author use the time domain process to define the degradation of the bearing. And this part we can show about the degradation of the ring from this. Says the green lines, it's equal to healthy conditions. And when we have a defect, a small defect, which is called error defects, it starts to degrade the stage. You can see the lines is not very linear, so it's degraded. It's hard to define the condition of the bearing based on the monotonic degradations or based on the time domain. That's why we propose a new concept to define the bearing degradations. Meanwhile, we have a problem with different parts of the bearing degradations. For example, for outer defect, if they have failure, will be have affected the housing of the bearing, and also increase the vibration will produce a noise, a big noise. So when you have a car, produce a big noise, it may be a problem at outer defect. Yeah. We have also inner defect. So inner defect is close to the shop, and if we have problem, we'll propagate faults to other parts like a gear or other bearings. So we have a misalignment. When we have a misalignment, will increase the degradation. So we'll reduce the healthy life of the machines. And the other part of the defect is a ball or ring bearing. And this is the worst part. When you have a ball bearing problems, will have produced a small portions to the oil. So we have normally inside the machine, we do the lubrication process, lubrication oil, and all the lubrication oil will be affected to the polluted by these tiny small portions. So by these conditions, we have to define each part which have defect, because if we can't detect it, the degradation of each part, we can propose a new maintenance conditions. Meanwhile, we have problem because the machines, the bearing are inside the machines, and we cannot detect it as a visual condition. So we can only predict it. That's why I'm using hidden marker model. It's like a multimeter. So we know that it's like just like a gambling. What is the condition of the today? It's very hot outside because no one's using the umbrella, or someone using the umbrella. It might be it's not raining, but it's very hot outside. So have two possibility. For the state of the art, I'm using so the condition of the signal is based on cyclosine rate. It's the ideal conditions when we have amplitude repetitions. So in real condition of the industry, it's very hard to have this condition, the cyclosine rate. Normally, we have a noise. We have also with predictions of the early degradation. It's a very small amplitude, and for each bearing, they produce a unique periodic amplitude. While we can see that in outer defect signal is different with the inner defect signal, also for the ball bearing. And in real conditions, one bearing can be affected to not only a single fault, but a multi-fault, and also multi portions. So the mainly contribution of our research is to propose a new dual branch hidden marker model. Normally, we are using only hidden marker model, and we can track the BPFO degradations. Why we use hidden marker model compared with the other authors using the deep learning? Because deep learning consume a lot of time, consume a lot of machines process, and the hidden marker model can be used in industrial case, even small machines. And we propose a new harmonic-based degradation representation. Normally, after using the time domain, in our case, we use the frequency and also the harmonic. And for robust, it's very effective for noise and sequencery, and it can be used for multiple conditions. Also for propagations in the condition. And for our case, in for this conference, I'm using the bearing simulations. Even I have real data sets, so I generate a simple frequency with the real conditions from this parameter. And for the scanner, I produce two single fold BPFO, BFFE, and also the combination of BPFO with the separate condition. So this is separate conditions. We have the crack, loose crack, and spalls, and we propose this dual branch using dual multiple states. So this is our methods. We start with the equation. In this case, we generate it from the several equations. In this presentation, I didn't show any equation that I'm using in conference article. So after this, I'm using the preprocessing signals. The signal processing is either transform and generate envelope signal. It's a combination of Bloch and also the envelope spectrum. And for other process is to extract the features. For we can define the several harmonic in this from the transformation of FFT, phase-forward transform. Define several harmonic, and this harmonic will produce amplitude, and we. Because we're using the hidden Markov in discrete conditions, it must be scaled. So I'm using the GMN mixer model clustering to define the symbol. And we use it for the dual branches Markov model. The two branches can be active in the same condition in parallel. So it can be healthy in BPFO or in this medium in one condition. So it's run in parallel time.
Like me.
Okay, sorry. So this is the result. It's a generated signal. It's auto race. It's also for inner race. So which is the hardest for inner race? It's mostly hidden by the noise. It's not too high amplitude compared to outer race. And this is a combination for two conditions of inner outer race, the signals. And we use the amplitude signals at the amplitude, and for the first BPFO, can you find in early condition is a very weak amplitude. It's normal the harmonic, and also for the inner conditions, it's with the bend side of the shaft frequency. So it's effective. We'll define the BFFE. After it, I'm using the clusters, so it's more easy to define the cluster in BPFO. So its difference is very high. For the BFFE, it's very close difference. And sorry, so the conversion is problems. So it's this is my transitions probability for hidden Markov models. So we have close branch. Even in this condition, we do the flow for the healthy to degradation. It can turn back to the previous conditions. And so for the accuracy, yes, and it's 100% because it's generated signal. Even I actually am also working in a real condition for laboratory, and it's produce 100% accuracy for a single fold for both predictive BFFE and BFFO. Also for the multi-fold degradations for BFE, BFO. And this is the conclusions. We propose multiple branch hidden Markov model, and we can track and also it. Okay, merci. Thank you. And
Can I do just a quick question?
yes.
Thank you for your presentation. You put not so simple, but really nice. I was wondering, you haven't tried this model with real data yet,
Yes, I do.
and it is working well?
It's working well.
Okay, so why didn't you present it here?
Because I spread it, it's for a conference, it's for article journal, something.
Okay,
Yes.
okay, thank you.
So thank you very much.
Okay.
Yes. So now I will go there.
It's online.
It's virtual.
Agora.
Este. Eu posso partilhar ou a pessoa vai apresentar?
Normalmente, quando é online, a pessoa está. É que partilha.
Exatamente.
Diz
Ok.
isso. Sim, sim.
Ele já está na reunião que eu já vi.
Já, ok.
Já posso ver. Só preciso ver.
Ok. Depois eu partilho.
Mas posso. Eu fico aqui. Ah, ok. Posso então?
Pode.
So now let's move to the third one that will be presented online by Belchior Miguel, and you present the adaptive sample design for basin spatial risk of maritime surveillance in Central Portugal. Just to check if you are learning, Belchior. Good afternoon.
Good afternoon, thank you.
No, we are not listening to you.
Good afternoon, can you hear me?
No.
Hello?
See if
Good
you are
afternoon.
mute, Belchior.
No. I'm
Try
not
now,
mute.
okay?
I'm not
No, you are
mute.
not.
Sai e entra outra vez.
Sai aí então, Belchior. Paula Simões, pode ir entrar outra vez, faz favor.
Ok, tá bem. Obrigado.
Ontem resolveu.
Não era a rede. Estava vermelha a rede. Pois.
Good
Can you
afternoon.
try again now?
Yes?
We are
Can you
not
hear me?
listening to you. You can check if you. Pode ver se as definições de áudio se estão a partilhar, se permitiu aos.
Sim, permitido, sim.
Que ele pede nas definições.
Pode ser o browser que ele está a usar.
Ou o browser.
Oh.
Se for o Chrome, é o que se está a usar aqui. Funciona.
Nós estamos a usar aqui o Chrome.
Ok.
Será que não é isso?
Eu consigo ouvir.
Será que aí o som está ligado?
Tá, aqui está.
Tá.
Está-me a ouvir, não está?
Sim, eu estou.
Pois.
Não sei se consegue ouvir.
Mas da audição nós temos, ele ouve-nos.
Certo, está ligado, está tudo ligado.
Está tudo.
Eu estou ligado, sim.
Não estamos a ouvir. Experimente só partilhar e verificar aí
Ok, deixa eu tentar partilhar.
nas definições de áudio e na reunião. Tem que pôr o mesmo que o sistema.
Será que os altifalantes estão bem escritos aí?
É isso que eu estou a dizer a ele.
Não, aqui.
Aqui está.
Tá?
Deve ser
Ou
para-
então aqui, o mesmo que o sistema.
E o
Não,
computador
mas
está
estes-
para cima? Aqui
Eu consigo
Eu
ouvir.
aqui não posso mexer, porque isto está preparado para ouvirmos na sala toda.
Sim.
Pois é isso.
Isto
Anyone
deve
in
ser de certeza
the
problema
meeting
do ar.
can talk to see if you can listen to you, please.
Yes.
Eu também faço.
Pois.
Eu estava a pedir a alguém que está virtualmente, se devia falar para a gente perceber.
Quer que eu ligue virtualmente? Para experimentar.
Consegue. É como eu não dá, também.
Ok, ele está ali. Deixa-me experimentar então. Porque há pouco eu ouvia daqui. Deixa-me ver então.
Vou chegar daqui.
Ana fala agora.
Consegue ouvir-me agora?
Assustou-nos, Belchior, assustou-nos. So, I'll switch to English. Can you share the screen your presentation now? Yes,
Okay.
switch.
You.
Okay.
Yes.
So you can start whenever you can. Yes.
Okay, thank you. Good afternoon, everyone. My name is Belchior Miguel. Can you hear me?
Yes.
Okay, thank you. My name is Belchior Miguel. I will present our work on adaptive sampling design for Bayesian spatial risk mapping of maritime surveillance in central Portugal. This presentation has 5 parts. First, I presented motivation and the study areas, data and the spatial models, adaptive sampling design, results, and the conclusion. Then, Portugal has a large maritime areas, but inspection resources are limited. Fishing-related infraction are not equal distributed. We use the risk maps can support inspection plan. Our objective in this study is to identify where inspection should be concentrated. The study area is the central coast of Portugal. You can see in this map, include the Figueira da Foz, Leiria, Lisbon, Setúbal, and the Sines. Coast petrol vessels operate near the coast. Offshore petrol vessels cover area of the exclusive economic zone in this area. The data include the inspection record from 2018 to 2017. The response is binary, presence or absence of suspected infraction. In this study, the infraction relating to fishing activity. So the red dot in this map represents the suspected infraction, and the black point, no infraction. We considered in this study 4-day periods of surveillance, 2 daytimes and 2 night times. We fit the Bayesian spatial model for binary data. The spatial round effect models spatial dependence, the integral nest Laplace approximation, and the stochastic partial differential equation give efficient Bayesian inference. The model produces risk maps and uncertainty maps. So the PC priorities, I use it for the special parameters. We compared the 19 models. The model O had the lowest DIC. In this model include the distance of cost, year, period, and the special effects. So then we use this model to generate the risk map and the sampling design. Now I present 2 maps of risk estimated, the night period. We can see in these 2 maps the height risk near the coastline, and see in these 2 maps of the night period. The strong hotspot around Leiria and Lisbon. In this first map is the same. And the large spatial concentration. And these two other maps represent the day periods. And we can see the more diffuse spatial distribution, the lower intensity than the night periods. The persistent hotspots remain visible. Now I will present the adaptive sampling design. We compiled three sampling design. The first is the stratified random sampling. Select the location randomly. And the second is maximum risk sampling design. Select high risk location. And the last is the maximum variance risk sampling design. Select location with the height uncertainty. Now, we compare the tree sampling design using the 200-point simulated. The binary outcomes were simulated at the suspected infraction with a Bernoulli distribution using the probability equal 0.2. And in these three maps, the red point represented the suspected infraction, and the blue point represented the suspected infraction, and the red represented the no infraction. We can see also the first map is the stratified random sampling, the remaining random, and the maximum risk sampling design concentrated at risk zone. We can see this. In the last, the maximum variance risk sampling design balanced risk and uncertainty. Now we present the surveillance routes. The selected location can be converted into patrol routes. We can see in this map, the first map, two routes enable simultaneous operation. In the second map, one route is the continuous cost monitoring. Then the route planning connecting the statistical maps with the field operation. Here I will present the comparison of the performance of sample design. We compared the three sampling design using the RMSE, log score, and the LGOCV. For 50 points, we can see in this table, for 50 points, maximum risk sampling design performed better. So for 20 points, maximum variance risk sampling design achieved the best prediction accuracy. And finally, I present the conclusion. The Bayesian geostatistics provide useful risk maps for maritime surveillance. The risk is height near the coast and more concentrated during the nighttime periods. And the max risk sampling design is recommended when the priority is detecting an infection. And then the maximum variance risk sampling design is recommended when the priority is reducing prediction uncertainty. And finally, the sampling design should be integrated with the operation routes planning. And thank you very much for your attention. I apologize for my English. I'm not fluent. Thank you again.
So thank you, Belcher. We have plenty of time for questions because we will use all your time. So, is there any questions or comments? No. So let's thank again and wish you
Thank you very much.
thank you, Belcher. So now, we will present the last one.
Yes,
The first
the
one.
first should be Sampaio, but he is embarked.
Okay, the first one,
So I'm going to talk about
investigating the
mechanical
operation.
engineering. So,
Can choose the
yes,
presentation.
yes.
This?
Yes, this. Let me see, yes. After we will open the other, okay?
Ok. Que
We can't, yes, that one. I don't
Ok.
know if we have.
Melhor depois.
Ok.
Eu fico aqui. Então, se não. Ok, que saia. Consegue. É porque eu tenho que
Que
partilhar.
falou,
Ah, tá bem.
Já
Eu
vamos
venho
ver.
aqui. Quando
Tá
for
bem.
para. Deixa-me só
Tá.
partilhar. Deixa-me só aqui partilhar. Ora, partilhar.
Não deve estar muita gente a ver, mas de qualquer maneira é uma garantia.
Mas tenho que
Exatamente.
colocar. Modo telas.
Okay, so the first one will be about investigating the operation of the railgun system with laboratory propulsion. So when you're ready.
I'm ready. I'm always ready. This work, it's the result of a master thesis some time ago. Pedro Pereira Sampaio should be here, but he's embarked. So it's me. My paper here was a co-advisor with Professor Mairo Gata, but my co-advisor, it was in the sense of mathematics. So I'm going to talk everything about not mathematics. Let's see. Here is the usual summary, introduction, methodology, empirical application in some discussion and results. In introduction, I start with some story. Why? Because the basis of this equipment that is a weapon, it's the Lorentz force. Lorentz force just results of the movement of the usual current, electric current. But this kind of sense just appeared many years later than Thales de Mileto that discovered that in old times, in ancient Greece, if we rubbed amber with a sheepskin, some strands of straw just were attached to the amber. So we discovered that there was some attraction between some corpses. But of course, he shouldn't know why, because it was too early to know that kind of things. Later, only in the 16th century, this kind of electrical and magnetic forces were studied with some rigor, scientific rigor, by Cardano. So it was just a lot centuries later. More or less in the same date, the magnet was published. So we can say that finally thing there was, so we could know that there exists electromagnetism. And this was in 19th century. Gilbert studied also, not Gilbert Christian, also understood that when the electricity, the industrial electric current caused disturbances when a certain compass was working. So there was some forces and some certain interaction. That's when we just discovered electromagnetism. In that sense, later, of course, we had that sense, and finally Maxwell established the equations. But notice we are talking about the 19th century. This weapon uses the concept of electromagnetism and the Lorentz force, and only happens in the beginning of the 20th century. Later, but still in the first half of the century, during the Second War, also was proposed electromagnetic cannon, but anti-aircraft. So we can see that only at the beginning of the century, at first part of the 20th century, this effect was really used, not for a good purpose, but always like the atomic bomb, yes, but it's always like that. In the sense of defense or attack, I don't know, but I prefer not to know. But it's an important thing to know that electromagnetic camp, when the current just flow, it did induce an electromagnetic camp, and we have Lorentz force. Okay, that's nowadays. At the end of the century, 20th century, with the end of the Cold War, this kind of study was a little less impactant, but nowadays it's again just reborning, but in a strong way. China, Australia, India, Japan, USA, all of them are just impulsing this kind of things. I don't like the idea, because the big power countries are just imploding with weapons. Okay, so why we are here to get acknowledged as our students. This was idea of the Sampaio, not mine, not Gata, but Sampaio. He wanted to study this kind of weapon, to know how it works, to know if it was useful to our Navy, and of course, to understand what was the technological evolution and what advantages would be for us as Navy, not for me. So the idea was to address the basic concepts, okay, underline Rainer again. The idea is very simple, we are going to see. Focused with electrodynamic questions, you have a number of pages of calculus where I entered supporting the solution of linear and nonlinear equation, EDOs. I don't put here one equation of that, so we could end it in time. And basically, what was sense? It was sense we have built two railguns, one very short one to study the materials, the reaction, what effects, collateral effects you could have, and studied kind of materials you could use, and what can be more damageable or not. For example, the first railgun, it was a very short one. It was in with the rails, with aluminium, and the projectiles in steel. The second one was different, was in copper, because it was much more with conductivity. But we noticed that both of them have really problems with damage, because these kind of weapons are subject without high level of temperatures and other impacts, so they can be easily damageable. So what it means that it's not a long-term weapon. It just it doesn't last lots, and it's not easy also to storage. So let's see. I can just in first phrase, we have everything. Lorentz force has been known for over than 200. It was what we have said, but its application in a railgun was not immediate. There were differing opinions about this theme. Only recently, its use has been considered a great interest, and the construction of fully electric arm machines has increased even more this interest. Why? Because it's very hard to have energy and energy quantity enough to be, and the procedure of charging the weapon and to charge, repeat to shot. This interval should be the minimal, and the charge should be also the minimal. And this process is not so easy at all, and it demands a lot of energy. And in the sense of a warship, it's not manageable so easily. That's why with electric issues, we can maybe arrange this problem. Here I destack the Checkmate project. It was a project of millions, but I think that it was in context. They don't say that, but I just associated from where it came and for its age has. I think it was developed in context of Iraq war. So this was in the sense of this, and it was very developed in this time, and it was very improved relative to the previous versions. After this, it just got warm, and after the 2010, we have again more increasingly these projects about this. Okay, it's easy to me to say 5 minutes. So I have all here more or less what I have said, but I need to say the second paragraph. These systems accelerate the conductive electrical design that bridges the pair of current carrying rails. The advantages of this technology brings to weapons systems include very high speeds, 2 kilometers per second or 61 Mach. A Mach, I didn't know, but now I know. It's the velocity ratio between the velocity of the object over the velocity of the sound. Okay, it's just so here again greater safety in the munition storage and the ability to use primary energy sources, electrical in tanks and ships, and this is important to this. Okay. Instead, the chemical inspections of gases and are toxic to humans. So, ok, agora eu preciso. É outro.
Este?
Acho que é esse. Está mal escrito e tudo, mas é esse. Ok, tá bom. É.
Só vou partilhar, tenho que partilhar sempre.
Ok, tá bom.
Depois vai voltar ou vai só?
Não.
Ok.
Já só tenho 5 minutos, chega.
Ok.
Epá, isto está muito pequenino, eles vêm bem. Ponha-me isto mais largo, se faz favor. Não dá? É para a largura da coisa, senão... Acho que ninguém vê, mas não faz mal, eu vou baixando para isto. Não faz mal. Como é que eu vou? Ok.
Não sei se vejo.
Vou. Isto é um bocadinho. Ok. Cá está aquilo que eu quero. Eu não passei as contas, atenção. Só quero mostrar aqui umas coisitas. Epá, isto já estou no fim. Está quase. Bem, eu nem sequer estou a pôr aqui os principais tipos de railguns. Isto são os principais problemas que aparecem. À esquerda, de principal, só temos português. Então é mais... Okay, this is principal problems that happen in railguns. In the on left, it seems like a drop of water. It's just a hole in that form that it happens in the structure during the extreme conditions. In the middle, we have some. I have here. Sorry. At the center, we have also some damage. And on the right, we have some deposit of excess of yes, some excess of materials. Now I'm just going down. Here I want to realise the kind of storage that we need to operate with the railgun. The two first. Three. I just reduce the next one, okay? Ok. Onde é que está aqui? Está aqui. Está aqui. Já o deixei passar, está aqui. Ora, eu queria aumentar isto e eu vou aumentar um bocadinho. Ok. Here we have the kind of capacitors that we have to sustain our railguns. The first two lines, it was what we have managed with our two trials of railguns. Notice that they are substantially different from the others, but the first two were in laboratory, in our laboratories that are not expected to provide this. It was just two different experience to touch the physical principles and to know how materials react to that. The follow that projects are important, and to see that the kind of capacitor is just with the quantity of energy that they are huge, and it's hard to manage with this kind of inert energy. Even our personnel, in particular in our Navy, they are not used to with this kind of energy. Our student that worked in first and second line of quantities of energy, we had a lot of care, and it was we thought that our laboratory was going to explode, but not, happily. So we have here some equations that I'm going to jump. Here is a kind of geometry of our projectile from two kinds of different projects, the General Atomics and the AM gun project on left and on right. Here we have a measure that how they are. Da ideia, deixa-me ver mais bonecos que eu estou aqui What we have done with our, we tried also to design the capacitor. We have to design the dimension of our projectile. We have used some steel projectiles. We have used some copper projectiles, different sizes, different materials. And also we need also to improve everything in that kind of. For example, we have used 1 centimeter, 2 centimeters, and 0.5 centimeters in the laboratory size rain gun, and the best result what was with the bigger the 2 centimeters. The copper revealed not so good because he was good to the propagation of the electricity, but it was too heavy for the remaining things. It was too soft for the impact of the ton. So it revealed also problems with the stream conditions. I'm just looking at here pois, yeah, here are the results that we are saying: damage in the rails, there's damage in the projectiles. We can see here the all problems that we are just saying that we are in extreme conditions. So it's not so at all. I'm just localizing here more things. Again, I'm going to, here is just our scheme of the two rails, and the projectile was put inside between these rails. Also, the rails revealed that needed to be with a certain form, with a certain length. We tried to several lengths, etc. I can't just explore everything, but I think I can. Yeah. Okay. So next. Posso concluir mais alguma coisinha? Ou já está? Ok. Ok. Pronto. Yes.
And the next one, that is also Filomena
With Teresa. Exato. É só este aqui de baixo para pôr o PDF. Acho que é esse. A ver se eu não falhei. É esse. Pronto.
É este. Pronto,
Tá,
passar
tá.
a partilhar.
Tá bonito.
Tenho que fazer sempre isto.
Está decente, sim. Eu costumo ter apresentações.
Ok. Vamos fazer isto.
Move to the last presentation, that will be modeling risk in HIV care, data-driven approach to patient profiling.
Thank you very much. This is a work that I had in Madrid just some years. That's true. But I saw it was written some time ago. This is a joint work with Teresa Oliveira. And let's see the usual contents, abstract, preliminaries, empirical approach, results, and conclusion. What we have, the main objective of this work is to model the lifetime of a group of 100 individuals with AIDS. The provided data, like most cases of survival analysis, are censored, right-censored. Size studies usually carried out over a fixed period of time. This means that or there are deaths or just the time it's cut, okay? In addition to this study of the distribution of lifetime T, another essential point of the statistical methods applied to the comparison of the distribution T in different groups, modeling the relationship of T with different explanatory variables associated with each individual. In the first phase, the non-parametric survival function was obtained. Next, we try to determine the relation between T and various covariates associated to each individual, which were assumed to affect life expectancy, namely age, type of drug used, using the proportional hazards model. Here are something that I think that it's common sense. The survival function is defined as the individual surviving at an instant T and it's being given by this in first formula. It's this probability of an individual survival of some instant. The failure or hazard, failure rate function of hazard is just defined as H, and it's the quotient, it's the probability of an individual dying in the next instant, knowing that is survival and equal T. It's just defined like this in the last formula. The cumulative hazard, it's given by, as definition, no, it's just an integral and it's given by this. It's important to understand whether the data to be studied correspond to moments of death or censorship. We don't know if it's one thing or another, given that they have different approaches. At the early stage, it's important to check some estimate of survival a function only after a qualitative analysis should models be estimated according to Cox proportional or others. The survival function of Kaplan-Meier is given by this formula. We know this. It's from literature. Here, NE it's number of individuals in risk, D before T. D it's number of deaths in T, and L numbers of individuals censored in T. In this interval that's between T plus Ti plus 1. NE, exactly, it's defined here, and it's the number N minus the numbers of deaths occurred until that time minus the numbers of individuals censored. We also need to construct some confidence intervals, so we need to know the variance or the estimate of variance. We use for these confidence intervals for some survival function plots, we use the Greenwood estimate for the variance. And we have here the Cox proportional hazards models. The Cox proportional hazards models, diz-me depois quando for. Tá bem? Hazards model is one of the classes of regression models. There are models with proportional failure rate. We call these hazard proportional. In these models, it is assumed that given two individuals with associated covariate vectors ZE, the ratio HTZ1 over HTZ2 does not depend on T. So with this premise, we have exactly that HTZ, it's given by the product of H0T GZ. With this possible structure of G. This is given by exponential of beta TZ. Okay, this assures the positivity, and beta or beta T just measures the effect of the covariate. Okay, that's the usual of linear models. In each coefficient beta E associated with each covariate, it's often called the risk score associated to the variable ZE of C. So it's just some nomenclature, can be other. What structure of the survival function for this model? So we have this one, STZ is given by S0T with the exponent of GZ. We have this also. We have here the verosimilance given by this. That coming back to the failure rate auto-estimated, Cox model, it's non-parametric. Obtain partially parametric model do this influence to covariates. Cox function is a Cox function that behaves like a likelihood function. That's why we have here the L. It's like likelihood function, not depending on non-parametric HRT. So we are just separating blocks so we can handle easily with things. This function is given like this product that's given by this. R is set of indices of individuals at risk at instant T, K, number of deaths, and the number of individuals under study. A generalization of the Cox model is to admit the existence of non-proportional hazards between strata. So, given by this, HTZ, it's HT GZ. As any regression, we have all the inherent model validation steps: variable selection, model comparison, residual analysis, identification of outliers and influential observations, verification of Cox proportional hazards, hypotheses, etc. Note that the tests used in linear models are again used in this context, like integrated, likelihood rate, etc. Since we are estimating several survival functions, it's important to mention the existence of comparison tests between different functions. In the test used for this purpose is the Matalan-Savage or log-rank test, which, despite adding no independent frequency tables, is quite powerful when the failure rate functions are approximately proportional. Our approach, we have 100 individuals, ID its identification code, time survival time, age in years, drug, if it has intravenous use, yes or no, use status, as if the death it was due ID to SIDA, or if it was a censored case. Here are the Kaplan-Meier estimates. We can see this is not still in strata, the total data it's here. Here it's the censored data, and we can see the interval. This is the empirical one. The next, this is disaggregated with strata, by strata, for by the type of drug, insensitive if it's intravenous or not. And you can see that the longevity of the curve, that it's above, and the less longevity that the curve corresponding to the curve it's just at bottom. I think, let me see the, we have, it's the comments that we have. Okay, both curves have the concavity facing upward and are similar to exponential distribution. Associate to no use of intravenous drug evidence higher, it means each time of survival. We have done other curves, we have not all things, but this fact evidences that we can or shall consider variable drug shall be considered in the model. Other variables were age and gender. They also were considered as covariates in model. Here, the first model, I am not putting everything. Here, I used S plus. Okay, it's perfect. I'm almost. Here, I use drug and age. For the, I have here always the codes, but we can see the results and we can exactly see the coefficients beta for the age and beta for the drug. They are over 1 and they never include 1. Notice it's important. And the p-value associated, it's very, very low. Okay. So we can see that it's significant. The next, I'm always looking for this model. The Koch populations are for this drug, for these two, consider these two covariates. We have here the curve. Now the next, the model 2 only considering age. All tests were again largely significant when compared with the previous model. We can say that they are again very similar, and again here a model with age, and here we have next stage estimate models for each level of drug. That and for each strata we introduce the age as covariate. And here the model was again also very, very significant. Again, same thing. We used log-rank test and compared the several curves for the two strata, and also we can get a p-value very, very small. It's important to us. It's largely significant. That's a clear difference in survival functions between strata. Age variable is statistical significant. And for model 3, again, we can see that the curves of Cox survival per strata are clearly different, as the proper model just saying that same thing. The final results I have here, the expression of the model. Here, depending on drug values, and it can be concluded that risk factor increases. This is 1.1 when the age increases 1 per year at each drug level, and the 95% risk confidence interval it's given here, 1.06, 1.14. Again, in model 3, it's clear that the age is important explanatory factor in the survival of the individual. I have again per strata, and again I have the same thing, and we can get the same conclusions. Okay. By 1 year, it's again same conclusions. Here we have something that we can compare. In the model 1, the risk obtained at 95% does not contain 1, and it's given per year that was seen previously, 1.06, 1 contains 1.14. Age, it's an important exploratory family. But regarding the drug variable, if it's judged from 0 to 1, groups of individuals whose intravenous drugs as higher risk factor is given by 2.76. It's a big step in sense of higher value. The relative risk interval obtained at 95% does not contain value 1, and there's an extreme well above the interval obtained age 1.67, 4.65. And I think I'm forbidden, yes?
No, the question time.
Okay, don't.
2 minutes.
So I'm just. It can be concluded that most models agree with on the conclusions. Age is an important variable for an individual's survival. The drug is an important factor for survival. In both models, it was highly significant. For future work, we intend to explore same data, but knowing that database was limited, the next step would be to add more information such as gender, familial diseases, etc. We would also like to apply other techniques that have emerged more recently, which are extensions of methods used in this work. I don't know, but I think yes.
So thank you.
Yes. I understood this data are Portuguese data,
Yes, it's Portuguese data.
and but I didn't get the outcome was death or was the identification that people that were infected with AIDS?
They were already infected with AIDS, but they were when this study was started in a certain interval of time. They were in the same stage of the disease.
And the
It
time
was,
60, it's a month or days?
no, was more than 1 year. I don't remember exactly, but it was fixed. Some of them died. Some of them eventually got better because we had a new,
Yeah, the return value.
yes, and others don't because they continue with this, and it's not okay in sense. It's not a model okay, for their health.
So this data was you
La-
got this data from
from medical group, but only that. And that's awful to get data from medical group because they never have everything complete. It's everything, some detail it's missing, and sometimes we need to not use everything because we can't. But it was what we could to do.
Thank you. So thank you again. I would like to thank all the presenters and the
Yes.
audience to be in the computational methods, statistics, and industrial mathematics. That will be the last session. So
Yeah.
thank you.
Thank you very
I don't know
much.
if the presenters will be online, so thank you very much.
Thank you to everybody. And by your perseverance, I think your article was that one that somebody had said, oh, it has a E or something, yes? Or, no, it was your article that somebody just declared, and you just responded to me, and I put, yes, it's valid. And after that, somebody again, and you put same response, yes? So thank you, your perseverance, because you just didn't quit.
I don't know, but to me, I right now because I'm writing and after maybe you're using the what's called grammatically, and after outbounds, and we're using several AI detector, and in this case there are no, and other place it's unwanted. So I'm thinking that the problem comes from the gravity. So that's why I'm not going to use it gravity anymore.
But notice, last year I have one problem. It was not this. They declare my article has 80% of copy. But it wasn't, they couldn't.
vicino. Sì. Sì, sì. Ok. Ma oh, non fare scherzi, fra. Okay, you can see me? Uh, you can see me?
Hello, everyone. Can you guys hear us? Hear me?
Hello, everyone.
Hello.
I was wondering if Marina is here. Texas. I guess it's break time now. Or Hello, I can see Halima and Sulav joined the meeting. Just wondering if you can hear me.
Yes, we can hear you, Professor.
Yes, we can hear you.
Yes.
The chair of the next session is here. Nahi, Duzaman, or Hassan.
Yeah, sorry, I can hear you now. I couldn't hear you earlier. Is it Marino or?
Yes, yes.
Okay, okay. So I'm waiting for Hassan to join, Professor Hassan. He'll be chairing the session. I'll be co-chair, but he'll be leading the session for the entire time.
Okay, okay, thank you.
So we got like 3 minutes more, so he'll be joining soon.
Okay. We start to 4 p.m., so.
Sure, yeah. Professor Redwan, do you hear us?
Hello?
Professor Redwan, do you hear us?
Professor Nahid, I can't hear you. No, I can hear you. Hello, everyone.
Yeah, can you hear me, Halima?
Yes, Professor. Hi,
Yeah,
Professor Redwan. Hi.
Professor Redwan, I think you are mute. Your mic is on mute, Professor Redwan.
Okay.
No,
Hello?
Halima, you're okay. I'm talking about Professor Redwan. His mic is on mute.
Okay. Can you see my screen, Professor?
Yeah, I can. I can hear you well. So both are fine. So Professor Redwan, could you unmute your mic, please?
He has an issue with the mic, Professor Redwan.
Okay.
Yeah.
I'm sorry. Marino, can you hear me? Sorry.
Yes.
Yeah, there's an issue with Professor Redwan's mic. He doesn't seem to unmute his mic. I was wondering if you could unmute from your side. Is it possible?
We don't wait. But the problem is not here.
I see. With his system, right?
Yes.
Okay. Okay. Give me a second.
I heard you and
Yeah, I was able to even unmute the mic and my video as well, but for his end, somehow he cannot do that.
okay.
So give me a second. Let me talk to him.
Okay.
Yeah, sorry. sorry about the delay. It's always technology. Sometimes they're blessing, sometimes be a curse. So let's see
Yes,
how we can handle that in a few minutes time. Sorry about that.
no problem.
Yeah,
You wait.
thank you. Professor Edwan, do you hear us? Can you hear me? No, we cannot hear you. Sorry.
All presenters are online now.
Yes.
Believe? Yes.
Yes. Hi.
Okay, hi. Ora, Salvador, Slav, and
Sorry, there is an issue with Professor Radwan's microphone, and he is getting a message saying error obtaining microphone permission. Is there a permission that you have to grant, Marina? Or? Can you hear me? Marina, can you hear me?
yes.
Yeah, I mean, Professor Radwan has a problem, and he's getting message that his microphone is not getting permitted.
Okay.
I don't know why.
Here we can't do anything. So.
Yeah. Give me a second, please. Let me talk to him and get back to you. Sorry about
Okay.
that.
Okay, no problem. Thank you.
Sure. All right, I just talked to Professor Radwan. Unfortunately, his mic cannot be activated. Somehow there is a connection issue somewhere, and we couldn't figure out. Sorry about that. And Professor Radwan also apologized for not being able to do that. As he's suggesting, so let's go ahead with the session. And let's be on time as well. And thank you, Marina, for your support with us today. I appreciate that. Yeah.
It can try change browser, but I don't know if it works.
Okay, just a quick note to Professor Radwan. Could you kindly change the browser and if it works?
Yes, Chrome, for example.
Professor Radwan, can you hear me? Could you kindly share the browser? I mean, change the browser and see if it's working there. Okay. All right. So let's start. Sorry, let's start. We lost time.
Yes,
and
it's
once
better.
again, apology for the technical issue, and it's unfortunate that the Professor Radwan could join, but he is joining us through the headphone, at least listening to us. Thank you, everyone, for this session today. This is ICCSA 6th session of 2026, and our session is quite interesting, very compelling to the part that we are looking at land use changes, urban transformation, and how we understand urban resiliency at this club territory to see how we can make them resilient at the forefront of climate change, right? So we have wonderful 4 presentations today in our workshop. So I wouldn't be little less overdue in terms of saying the name. So I'll be starting right away to start the process. The first paper the title is actually Territorial Transformation in the Digital Age, Remote Work, E-Commerce, and Resilience Implications. So I'm inviting Halima Nasri to come ahead and present. Please go ahead, Halima.
Thank you, Professor. I hope you can see my screen.
Yes.
Hello everyone. I'm Halima Naseri, a PhD researcher in urban planning at Mohammed VI Polytechnic University at Sitinov for integrated territorial planning and smart cities, supervised by Professor Nayir Zaman and Professor Hassan Adwan. Our paper is about how the digital age is reshaping territory or how virtualization, namely remote work and e-commerce, are impacting territories, and what are the implications for resilience. This paper is the conceptual foundations of my thesis, where I built one integrated framework to read these changes all together. So let me start with why this matters. So COVID-19 was not only a health crisis, it was one of the biggest territorial disruptors in modern history. So when lockdowns came, about 90 countries shut down, and in a few months, we adopted 2 things on a massive scale: remote work and online shopping. Normally, this kind of changes takes years, but the pandemic compressed it into a few months, and crucially, this habit stayed and kept growing afterwards. Now, why is this different from past crises? It's that old crises, such as financial or industrial, mainly hit the economy, jobs, and investment. This one, which was the COVID-19, was changed space itself, where we live, where we work, and how goods move. It reorganized the territory, not just the economy. This spatial dimension is the heart of our thesis, my thesis, and this paper. So in this figure represents the map of the whole paper. So at the top, we have COVID-19, an outside shock. From it, 2 forces grow. On the left, remote work and e-commerce on the right. So each force then creates 2 territorial consequences. Remote work pushes housing demand out of the centers and leaves offices and retail empty. And then the second force is e-commerce that expands demand for logistics, land, and makes property prices diverge. So 4 consequences. And the key message at the bottom, these 4 elements are not independent, but they interact and reinforce each other. Now, the first force in detail, which is e-commerce. During lockdown, physical shops declined fast while online shopping expanded. Projections put online sales above $8 trillion by 2027, a 39% jump from 2023. But this is not only about shopping, it reshapes the land. More parcels means more last mile vehicles, and research projects a 60% rise in delivery emissions. Here is the simple idea. Every parcel delivered to a home is one trip that used to bring a customer to a shop. If we multiply that by million of orders a year, physical retail empties and demand for warehouses and delivery depots and logistic facilities explodes. The second force is remote work, and the change is just as big as e-commerce. So before 2020, working from home was about 5% of working days. In 2020, it jumped to around 60%. Today, it has settled near 28 to 30%, mostly, and it's mostly hybrid. Researchers agree that this is structural, not temporary. And here is the key link for planning once we do not commute every day. So closeness to the office stops deciding where we live. So we tend to live in the suburban area. So offices sit empty most days. And also city center shops and transits lose their daily footfall, and households start choosing space, calm and outdoors in cheaper suburbs and peri-urban areas. So we have two forces. Here is what happens when they meet. And this is the core tension of this paper. On the left, we have remote work that pushes workers out of the center. So suburban housing demand rises and moves outwards. On the right, e-commerce replaces shop strips with deliveries, so logistic land demand also rises and also pushes outward. They both land on the peri-urban ring at the same time. So the result is land use conflict, planning stress, and price distortion. And so just simplify the idea and give an example of a worker. So if a worker who moves from the city to the suburban area, that single person instantly becomes four things at once. A former office occupier adding to office vacancy, new housing demand in the suburban area, pushing up price in the area, and he is also a daily logistic customer that now is ordering online, and a lost footfall for city center retail. Now we will see some key numbers and trends from different contexts. So in North America, the shift is sharp. For example, San Francisco office vacancy went from about 2% to nearly 30. For New York offices, they lost around $90 billion in value, and U.S. housing markets, housing prices rose 24%, and half of it is explained by remote working. In Europe, it's milder and less harsh than in the US case because cities have strong transit and mixed use centers, so the pull to the suburban is weaker. For example, in London core areas, the prices fell while periphery gained. And in Portugal and Spain, they used what we call digital nomad visa, which bring money but raise local rents. In Asia and Australia, for example, Japan, they used phone data to literally watch people leave office districts, and they found that the footfall of the core areas dropped during and after the pandemic. And China's online retail over $2 trillion, and it also reshaped rural areas. So they started even building logistic facilities and warehouses in rural areas that are next to some peri-urban territories. And in some Australian cities, weekdays footfall is down 35%, while they recover fully during the weekdays. So let me zoom into the United States because it's the most documented case and shows the hard evidence behind the e-commerce force. So this chart counts new Amazon logistics facilities opened each year by type in just 2 years. So 2020 and 2021, they opened 687 new facilities. That is more than the previous 2 decades combined, from large fulfillment centers to small last mile stations placed close to consumers. So the e-commerce force is not abstract, it is physical: warehouses, sorting hubs, depots, and other facilities. And now for remote working, which is the second part of virtualization, these two maps show New York and on the left and San Francisco on the right during the pandemic. So the red means a zone that lost residents, and green means it gained. At the centers of each map, the city core, it turned red, so it means people moved out of the moved out to the suburban area of the same metropolitan area. This is the donut effect that we hear about, a hole in the middle and a gaining ring around it. And the key point: people did not leave the region; they relocated inside it. From dense core to the surrounding ring. That is exactly the peri-urban pressure we described earlier. So across all the cases and the literature review, three patterns repeat. First, diversified economies cope better. Second, flexible land rules adapt faster, where you can turn offices into homes or industrial land into logistics. Cities respond easily but get stuck when the rules are rigid. Third, and most important, the gains are unequal. So the benefits only goes to higher incomes or digitally enabled workers. So this raises an equity problem everywhere. So now the discussion is, and the gap we found, a lot of good research already exists, but each field studies its own piece alone. So housing researchers measures how remote work raises prices, real estate researchers measures office decline, logistics researchers study e-commerce land, and resilience scholars study shocks. So it's a bit fragmented. So our contribution is to put remote work, e-commerce, housing, offices, office vacancy, logistics, and logistic facilities, resilience, all into one single framework to understand these different dynamics from different angles. And going back to who bears the cost, so the equity problem is very important, and we are highlighting it in this part. On the left, we have those who gain. So it's either they work in digital jobs, so they get to live anywhere where they have bigger and cheaper suburban homes, less commuting, a better quality of life. And on the right, we have those who bears the cost, such as people that works or who works in logistics, care, hospitality, construction. So they cannot work remotely, so they pay higher rents in the suburban areas where people tend to move more often. They lose services as urban cores empty, and they face more delivery traffic, and also they risk displacement as rents rise around them, even in the suburban area. So we have same forces, opposite outcomes. So this is the importance of resilience, because and resilience cannot be designed for the winners only. It has to be designed with this divide in mind, to limit the bad consequences and raise the positive side of this virtualization process. So here we will be discussing resilience axis that we might develop and we will develop in subsequent papers. So what separates a territory that wins from one that is damaged? Across the evidence, three conditions come back first. Flexible land governance, by being able to convert commercial to residential or industrial to logistics quickly without years of rezoning, and without it, I think offices stay empty while housing and logistics fight over the same land. Second, robust digital and physical infrastructure, good broadband to keep remote workers, and well-planned logistics and transits for the new patterns. Without it, a territory cannot compete. And the third, last one is equity-oriented policies that protect affordability, prevent displacement, and keep services in declining course. And it's very important. Otherwise, adaptation just serves the high income and deepens the inequality. So these three conditions together can turn disruption into an opportunity rather than a danger. So, to conclude, the main message is simple. Work and e-commerce are not just economic trends, they are spatial forces, and cities are not going back to 2019. They are settling into a new baseline. In this new world, I think resilience means more than bouncing back. It means actively reusing empty offices, managing suburban growth, decarbonizing logistics, and sharing the gains fairly. And that depends on choices, on governance, on infrastructure and political will, not just on a city's location. And I think I will finish my presentation with this question. What future equilibrium do this dynamic create, and what resilience framework can make it sustainable, integrated, and equitable? And thank you so much.
Great, and thank you, Halima, for keeping the time. It's a good timekeeper, actually. So we have a few minutes for Q&A. So I'll leave the floor open to the participants for asking questions, any comments you may have. Right, I have just two quick sort of reflections, Halima. I was wondering if you could explain a little more, what is virtualization? What do you mean by that?
Actually, for now, virtualization, from what I've read and the literature review, it's the new lifestyle we are all adapting, even in countries where it is slow, it is unavoidable. So virtualization, it's remote working, and for example, mainly remote working and e-commerce. Yeah.
Like I mean, any business could be flown through the virtual means, could be virtualization sort of product, right?
Yeah.
And also one thing you mentioned in the statistics from US, right? The housing price went up back in the US, especially in the fringe areas. I was wondering, how could you explain more on that, the reasons and factors behind such price hike?
I think it's due to the trend of virtualization was faster and more strong and stronger in the US case study, and also people, I think it's cultural too, tend to live and choose to live in the suburban areas, which made the price of housing in the peripheral fringe rise, and it created a sort of real estate crisis in the peripheral area since the demand increased fastly. Yeah.
Absolutely. Wonderful. Good presentation, and thank you for the clarity of your presentation, and wish you all the best on your future endeavors. With that, thank you so much, Halima, for your presentation. So I'll be moving on to our scheduled next presenter. So paper is circular infrastructure for a regenerative wool economy, revitalizing the Italian sheep wool supply chain in the Mediterranean. So I would like to kindly invite Salvatore Bogano.
Good afternoon. Did you hear me?
Yes, very loud and clear. Yeah.
Okay, I load the presentation. Sorry. Okay. Do you see the presentation?
Not yet.
No.
Oh. Okay, now?
No.
Sorry. Sorry, I think I have a problem with the.
Like with sharing the slide, or?
Top right. Okay. I mean, in the presentation tool, but I don't know why we don't see the. I start the presentation, but.
I see. But if you press on start screening sharing, does that give you the chance to choose your file and share? Or?
Now? No. I put on start presentation, but I don't know why. Next slide.
Okay. But let's say once you click on the button, start sharing the screen, does that give you the chance to choose your file?
Yes, yes, the button, but I don't know why.
Okay. Maybe our tech support could help, Reina.
You can share in the icon of below in Zoom. Start share.
In the room.
In the Zoom.
Okay, I can try.
If you go down, there's some panel bar, right, where you have the mic, video call, and next to it there's a screen sharing button, right?
Presentation. Now?
Okay. Okay.
Yeah.
Okay. Sorry. Okay. Did you hear? Do you hear me?
Yes, we can see and hear you well, both. Yeah.
I'm Salvatore Bognano, and I come from University of Catania in Sicily. We focused our study in these particular themes because the Mediterranean basin. Sorry. Because the Mediterranean basin has been has always been considered as a cradle of small ruminant breeding. The mild spring associated with the production of spontaneous essences that have determined the decision of farmer to raise the sheep for the milk production. So the principal supply chain in this context is the milk production, like principal output, with the production of the wool with like second byproduct. But what is the wool? The wool represents the modification of the hair covering of mammals, with the primary function to protecting the animal from adverse weather condition. It is obtained by sharing the live animal either by hand or with the help of mechanical share in late spring. The fleece has been divided in an outer layer and an inner layer. The first one is coarser, and the inner layer is more valuable. Then we can classify the whole fiber in base of the fiber diameter. So we have textile wool less than 25 micron, cruise hull less than 25 from 25 and 30 micron, and mattress hull from 35 to 60 micron. The quality and the quantity of the hull produced by an animal vary according the sex, the environmental condition, and above all the breed. So in the table we can see the principal sheep breeding raised in Sicily and Italy. So these sheep are with a predominantly milk production aptitude, and we define there as open flitch type. With this type of hull obtained by them, this hull is of lower quality and is a lower quality, than that obtained from animal specialized in this production. So in the using yarn has been replaced by specialized farm located in southern hemisphere like Australia, New Zealand, South Africa, and Argentina. But in recent years, the wool has ceased to be considered a source of income due to the lack of a market, because the market prefer the wool obtained by specialized breed like Australian merinos. But the problem is the wool has become a form of special waste, because if left in open air, it's difficult to decompose and must be treated. The process of purification of the dirty wool involves sterilization at over 130 degrees, wasting a considerable amount of energy and water, with the cost disposal on the farmer. And in this context, we need to find an alternative. The project in general aims to develop a virtuous model for the recovery and the application of wool in the form of material useful for protecting the earth and respecting the environment. In Sicily, we have a beautiful reality. We have the Sicilian wool district, born in Camarata, focused on the valorized of the wool from native Sicilian breeds, transforming into a liquid fertilizer through an hydrolysis process. The idea on the base on the district is to create a supply chain to valorize the unused product, and the wool came from the share of native Sicilian breed. The dirty wool in the hydrolysis process, the dirty wool is placed in a reactor. In a reactor, and turn around an axis with water around 170 degrees. This rotation allows water to penetrate within the wool and in entire surface. Using a saturated steam produced by a boiler. The fertilizer obtained can be liquid or solid in pellet form, and it is current is currently tested in the field on vineyards and small fruit. Due to its characteristics, wool, when treated, is an exceptional soil conditioner because it provides carbon, nitrogen, and sulfur, the main nutrients for the plants. The disposal system has some advantages. For example, environmental, because it acts like a natural fungicide thanks to the sulfur within the wool fiber. Agronomical, because improve the soil structure, and economic, because it can reduce the cost of the synthetic fertilizer. We have another reality in Sardinia. In Sardinia, with the Edilana company. This company has been engaged in the field of the construction with the creation of products with extraordinary properties. The panel exploit the extraordinary properties of wool fibers, which, thanks to the high keratin content can bind and eliminate many toxic substances like smoke and fine dust. And also the Dilana panels, in combination with fir strips and sheep's wool, are used into Prontomat for their acoustic and thermal insulation properties. We can find another possible use in creation of fabric using an ancient manually technique called felting. By waving the fiber by manual pressing with soap and water. And so we have tool-free processes without any chemical or something else. An elastic fabric, perfect for clothing and furniture. A remarkable thermal capacity from hot and cold, and an excellent hygroscopicity, because it's capable to storing from 20 to 25% of water when wet, and around 50% when dripping. So, Another part of the project regards the nature-based engineering. As is well known, studies how living plants components, plants of part of them, can be used as building materials in combination with non-cementitious aggregates, such as stone, earth, wood, and steel. We have some advantages because, for example, we can preventing hydrological and mechanical instability by intercepting of the rain and by making a cohesive effect on the soil with the roots. The reduction of a lateral expansion of rivers, for example, combined the wool layer with stone within iron box, promoting renaturalization thanks to the food properties within these materials, and environmental impact mitigation because we don't use this structure. We use this structure, for example, near the river's bank, and with the vegetation we can hide the iron structure on the bottom of the vegetation. We have, for example, wool bricks. They are biocomposite bricks made by the combination with wool fiber, act like a straw for ancient bricks, creating a reinforcement that increasing tensile strength, stabilized the foot of the slopes, and being biodegradable over time, leave room for plant roots. We have biomats. They are also biodegradable mats placed on slopes to protect them from the surface erosion. In these mats, wool covers an extraordinary mulching effects. Thanks to the degradation, it leaves substances in the soil that can promote plants' growth by promoting renaturalization. And we have geomats. They are like biomats, but have more rigid three-dimensional structure. The wool is trapped in this structure and retains the smallest soil particle, preventing them from washing away, and they create an ideal environment for plants' roof. In the Italy, for example, we have the stone-filled gabions and box gabions. They are a low middle structure or filled with stone. Inserting layers of wood inside the gabion prevents the loss of the fine materials typical of traditional gabions. The wool allows water to pass through it, but not the soil, and allows the plants to grow in the gabion. There is a reduction of in the lateral expansion of rivers, and moreover, the wool can transform a gray work into a living green work. So, in conclusion, we can say that the use of revaluation of wool has numerous advantages. For example, provide additional income to farmers, because in these ways we can use unused byproduct. Stretching ecosystem services, preserving habitat and landscapes, for example, in the Banks River, and helping and reversing the process of biodiversity loss, because on this structure can rise the vegetation. Thank you.
Wonderful. Thank you, Salvador, for keeping the time. Appreciate that.
Sorry, can I close the condivision, or?
You might keep it for a while because we have Q&A now. So
Okay.
Let's see if there are any questions. You might refer back to your slide, right?
Okay.
So any questions and comments for Salvador? Just one quick thought. Thank you for the nice presentation, and it's a good paper as well. And I was wondering, what is the market share of the wool economy in Italy?
In Italy, we have a big problem, because with an absence of a marker, the farmer tend to cover and also burn the wool, and this is have a bad impact factor. but in reality, there is some institution help for this for this farmer that they have to pay the purification of the wool. There is some people that buy some bucket of wool, but at irrisory price. For example, 10 centimeters or kilos. So there is the problem is the Italian sheep are specialized in milk production. So they define as open fletch, and they have low quality wool.
Mm-hmm. Great. Yeah, thank you for the explanation. Appreciate that. So if there are no questions, I would like to thank you, Silverer, for the nice presentation, and wish you all the luck for your next endeavor. Thank you.
Thank you.
All right, with that, we are heading to our third presentation of the session today. So I would like to invite Sulaf Era from Sidinov EM6P Morocco, and she'll be talking about the paper titled Bridging Land Use Planning, Resilience, and AI for Flood-Induced Urban and Territorial Management. Sulaf, the floor is yours.
Okay, thank you. I will share my screen right now. So can you see my presentation?
Yes.
Can you hear me? Okay. Okay, so good afternoon, everyone. So my name is Sulaf Ata, and I am an architect and a researcher at Sidinov Mohammed VI Polytechnic University in Rabat, Morocco. And this work is a collaboration with Professor Nahid Zaman and Professor Radwan. So I will present our research on how these three areas that are often treated separately, namely land use planning, urban resilience, and the AI, can be integrated into a single framework to better manage flood-induced urban risk, using Morocco as the main case study. So let me begin by explaining why this topic is important. So the background of this research comes from a growing global challenge. So climate change is increasing the frequency and intensity of disasters such as floods, droughts, heat waves, and earthquakes. At the same time, cities continue to expand into areas that are highly exposed to these hazards. The problem, however, goes beyond climate change. It is also a planning issue. Too often, land use, infrastructure, and disaster risks are treated as separate topics, even though they are closely interconnected. Also, local knowledge and emerging technologies such as AI are still rarely integrated into planning, especially in developing countries. So this research aims to address that gap by developing a single framework that brings together 4 key elements: adaptive land use planning, multi-hazard resilience, local knowledge, and AI for flood-induced urban management in Morocco. So to understand why such a framework is needed, let's first examine why current planning approaches fall short. Over the past few decades, disaster management has evolved from a reactive approach responding after the disaster occurs to a more proactive approach focused on reducing risk before disaster happens. This shift is reflected in the Sendai framework, which recognizes that disaster risk is dynamic and constantly changing. However, in practice, there is still a major challenge. Many climate adaptation plans remain non-binding, lack sufficient funding, and are poorly connected to the land use planning regulations that determine where and how development takes place. In Morocco, for instance, this challenge is particularly evident. Planning often remains reactive, while hazard maps and local knowledge are still not fully integrated into planning decisions. So the central problem addressed by this research is the gap between understanding disaster risk and translating that knowledge into effective land use planning and implementation. So now for the next question, it is how can we bridge that gap? So this brings us now to the objectives of my research. So first, the first objective is to examine international experiences to identify lessons that could be adapted to Morocco. Second, to analyze Morocco's multi-hazard context, including its vulnerabilities and strengths. And third, to develop a conceptual framework based on three key elements, which are adaptive land use planning, the integration of local and scientific knowledge, and AI for decision making. And to achieve these objectives, I used a funnel approach, which is illustrated in the figure on the right. The analysis begins with the global context of climate-related risks and then moves through international case studies, the challenges faced by developing countries, and finally the specific situation in Morocco. So this step-by-step approach allows us to draw on international experience while ensuring that the proposed framework remains grounded in Morocco's unique context. So let's start now at the top of the funnel by looking at how planning has evolved from traditional hazard control to a resilience-based approach. Traditionally, disaster planning has treated each hazard separately, but in reality, these hazards are often interconnected and can trigger cascading impacts across cities and communities. This is where the concept of resilience changes our perspective. Instead of focusing on recovering after a disaster, resilience sees the city as an interconnected socio-ecological system that can adapt, learn, and transform in the face of change. So this idea is built on three main perspectives. The first one is the ecological perspective, which focuses on maintaining essential functions during and after a shock. Then the social perspective, which highlights the role of communities and recognizes that vulnerability is not the same for everyone. And finally, the urban sets approach, which emphasizes the interaction between social, ecological, and technological systems. However, there is one important limitation to highlight. In many cases, resilience strategies place too much emphasis on technology while giving less attention to governance, local knowledge, and social inclusion. And to see how these ideas work in practice, let's delve into two international case studies. The first case study is Rotterdam. Because the city is located in a low-lying delta, it cannot rely only on dikes and flood barriers to manage flood risk. Instead, it has introduced innovative solutions like the Bentham Plain Water Square. So normally it is a public square where people can relax and play, but during heavy rainfall, it temporarily stores stormwater. So it's a space that serves both the community and flood management, as it is clearly illustrated in these two pictures. Also, what is interesting is that even Rotterdam has faced challenges. They have dealt with issues such as limited expertise, gaps in data and funding, and even difficulties coordinating across different departments. And this reminds us that innovative designs alone are not enough. For Morocco, the main lesson here is that these institutional and capacity challenges need to be considered from the very beginning. Now, for the second case, we will shift the focus from engineering solutions to the importance of knowledge and information. Here in the Peruvian Amazon, the local communities have a deep understanding of local ecosystems and flood risks. But for many years, this knowledge was largely overlooked in formal planning. What made the difference was combining traditional knowledge with modern technology, such as satellite imagery and hydrological models. This hybrid approach produced much better information for decision-making. But the main challenge was integrating this approach into existing institutions, which are often rigid and slow to adapt. Again, going back to the Moroccan context, the lesson is clear. We also have in Morocco a valuable local knowledge, but it is rarely incorporated into formal planning processes. So what is mainly to remember is that resilience emerges from multi-actor governance rather than isolated technical solutions, and governance models must be adapted, not transplanted. And this brings us to the third and final ingredient, which is AI. Today, AI and machine learning are transforming the way we assess flood risk and plan for future scenarios. A good example comes from Puri in India, where the AI for Resilient Cities initiative combined geospatial data, deep learning, and multiple environmental indicators to identify the area which are most vulnerable to flooding. What makes this case especially interesting is that local volunteers also contributed by collecting field data, improving the quality and relevance of the model. So here, the key takeaway from Morocco is that AI should not replace human expertise or local knowledge. Instead, it should strengthen them by providing faster and more accurate decision support. So now, with these international examples in mind, we can broaden the discussion to the challenges and opportunities faced by developing countries as a whole. These countries are often the most exposed to flooding, but they also have the least capacity to adapt. Across literature, we have 4 major challenges that appear in a recurrent manner. First, there is a gap between the level of flood risk and resources available to manage it. Second, rapid urbanization has pushed more people into flood-prone areas. Third, governance remains a challenge with fragmented institutions, unclear responsibilities, and planning systems that often struggle to address long-term risks. And finally, there is the issue of infrastructure and social equity. In essence, in cities such as Dar es Salaam in Tanzania, inadequate drainage systems make flooding much worse, while in places like Nairobi, the impact falls in a disproportionate way on the most vulnerable communities. So these 4 challenges closely reflect the situation we observe in Morocco. So with this international context in mind, we will now turn to the Moroccan context. Morocco faces a wide range of natural hazards, floods, droughts, earthquakes, which all pose significant risks to people and infrastructure. Recent events clearly illustrate this. We have the 2025 flash floods in Sefi, which caused severe damage. The 2023 El Haouz earthquake highlighted the country's vulnerability to major natural disasters, and the 2026 floods near Qasr al-Kbir that showed a bit more of a positive outcome thanks to the stricter enforcement of prevention measures. So the key message is simple. When prevention measures are properly implemented, the impacts of disasters can be significantly reduced. In other words, good planning saves lives. At the same time, Morocco is not defined only by its vulnerabilities. It also has important strengths and opportunities that can support a more resilient future. On one hand, we have rapid urban expansion, which has increased flood risks in several areas, in essence, in the greater Nador region. Then we have the Tetuan example, which showcased that exposure is also social, as it varies according to gender and education. Then the Al Haouz example, where traditional earth, stone, and wood dwellings are culturally rich, but they are seismically fragile. As such, reconstruction must balance between heritage and safety. On the other hand, Morocco has a rich heritage of traditional knowledge that can support climate resilience. The Khtarat, which are underground water systems, demonstrate centuries of expertise in sustainable water management, while traditional vernacular architecture incorporates features such as thermal mass and natural ventilation. So the key lesson here is that these traditional solutions should not be replaced. Instead, they should be integrated seamlessly with modern planning tools and technologies to build more resilient communities. So this raises an important question. Despite all this knowledge and experience, what is still missing in the existing literature? First, land use planning and infrastructure are often studied separately, even though they are closely connected in practice. Second, many studies emphasize the importance of integrating scientific and local knowledge, but very few explain how this can actually be done. Third, while AI is gaining attention in disaster risk management, its application remains very limited, especially in developing countries. Finally, many resilience frameworks focus mainly on technical solutions, given less attention to social equity, cultural heritage, and governance. So these 4 gaps form the foundation of this research. And the framework I propose is designed to address each of them by bringing together land use planning, resilient infrastructure, traditional and scientific knowledge, and AI within a single integrated approach. So now the conceptual framework itself. The first pillar is adaptive land use planning combined with resilient infrastructure, and so ensuring that urban development reduces rather than increases disaster risk. The second is the integration of local and scientific knowledge, bringing together traditional practices with modern research to improve decision-making. And the third pillar is AI-driven predictive planning, using AI to support flood risk assessment, scenario analysis, and proactive planning for multiple hazards. So our synthesis presented in the following table also identifies 5 key conditions for making this framework effective. We have developing multi-hazard planning protocols adapted to the Moroccan context, formally integrating local knowledge into planning processes, strengthening and enforcing land use planning regulations, and improving coordination and governance across institutions. So together, these elements provide an integrated pathway toward a more resilient and sustainable planning system for Morocco. With that, I'd like to conclude by summarizing the main contributions of this research. So the main message is that there is no one-size-fits-all solution. Successful approaches from places like Rotterdam or the Peruvian Amazon offer valuable lessons, but they cannot simply be copied and applied to Morocco. Any solution must be adapted to the local environments, institutional and social context. At the same time, Morocco has important strengths to build on. These include a strong commitment to disaster risk reduction, a rich heritage of local knowledge, and growing technical and digital capacities. So the framework I proposed brings these strengths together by combining adaptive land use planning, resilient infrastructure, local and scientific knowledge, and AI. It also recognizes that effective resilience depends not only on technology, but also on good governance, social equity, and community participation. So I hope that this framework can contribute to future research and support more resilient planning in Morocco and in other developing countries facing the same challenges. Thank you for your attention, and I'll be happy to hear any comments or answer any questions.
All right. Thank you, Sulaf, for a quite intriguing presentation. I'll leave the floor open to everyone now for any questions or comments. Any question, any comments for Sulaf? Okay, I have one I would say reflection. Sulaf, thank you for the nice presentation. It's quite intriguing. I was wondering when it comes to local knowledge, or in other words, indigenous knowledge, right? That is really space-driven or context-driven. So what is the challenge do you see, or kind of the barriers to include those local knowledge into mainstream planning?
Well, first, since local knowledge is transmitted from generation to generation orally, it might be a bit of a challenge to get some written proofs or something concrete to be based on, because older generations have applied some of their expertise and they may not have written it down. So what should be done is go into direct contact with these people and spend some time with them in order to get a glimpse of their inherent expertise in, like, for example, flood management or any other hazard management.
Interesting. You know, that thing, if you look at the contemporary practice across the world, not only Morocco, even Europe, Asia, North America as well, there is a kind of negligence sort of, towards incorporating local knowledge. And that sort of, if you look at governance perspective of that negligence, it has a lot more further barriers, right? So I was wondering, given this governance barrier, or let's say not so interested sort of areas of problem, so how to address that? Because unless you have whole governments working together, right, in terms of cooperating and making linkage to each other, it's difficult to address one point and leave the others, because at one point you might be convincing people, but it might not go further, right? It might block somewhere next step, right? The question could be, as you said, it's a governance issue, right? It's a whole governing system issue. And how do you appreciate that? That's a big challenge. So what do you see, would be the triggering point or starting point to be starting with?
It is, as you said, Professor, the governance side is pulling the strings in everything here, especially in urban planning. So what I suggest, mainly incorporating incentives to encourage the incorporation of local knowledge within planning practices, maybe spreading awareness within the local population that their voice matters, that their expertise will add more and will help shape their realities even better, because they obviously have some complaints about how the their urban life is currently doing. So it is by involving them and by showing that they have an input in the matter that they will make a change with their own hands.
Mm-hmm. Great. I'll leave it there, unless there are any questions, comments for Sulaf. So wish you all the best, and thank you for the nice presentation one more time.
Thank you.
Sure. With that, we are heading towards our fourth presentation. The title is Spatial Heat Resilience Mapping Using Graph Neutral Networks. I'm kindly inviting Sonia Al-Najjar to come and present.
Good afternoon, all.
Good afternoon.
Can you see my screen?
Not yet.
No. How about now?
Yeah, it's coming up.
Okay. So, good afternoon again. Buenas tardes. My name is Sonia Al-Najjar. I'm presenting today on behalf of my colleagues, Professor Antonio Garcia and Professor Victoria Patricia Lopez. My presentation is part of my PhD thesis, which deals with urban heat resilience and urban heat vulnerability mapping. The title of this presentation is Spatial Heat Resilience Mapping Using Graph Neural Networks. So if you look at the big picture, we can see here a map of Europe, Western Europe, and we can see that last year the heat was at its extremes in the Iberian Peninsula, in Spain, North Africa, as well as the Middle East. And the stats as well tell us that June of last year was the highest temperatures recorded ever. And so Mediterranean heat waves are intensifying. Seville already has Spain's highest heat mortality risk. And if we look at the microclimate context, we need to find solutions for that. And of course, we need to employ machine learning methods for that. Unfortunately, standard machine learning methods treat buildings and as independent points, missing spatial spillover of heat between neighbors. So the goal of this paper is to improve on this part of research and to predict building level heat vulnerability with a graph neural network, a GNN. This graph neural network in this research modifies and models this spillover directly. So the research objectives, the specific research objectives are to first to formulate a microscale urban heat vulnerability index, integrating thermal exposure, vegetation, compactness, and park access for 29,542 buildings in Seville. Of course, the buildings are built within QGIS using OpenStreetMaps. And the second objective is to develop a topological deep learning architecture that learns neighborhood level drivers of heat vulnerability. Also to evaluate predictive performance and spatial error against ground truth index values across the urban fabric. And finally, to identify primary drivers of microscale vulnerability via feature importance on the highest risk predictions. So in this research, we are using 4 features, LST, NDVI, building compactness, and park access. Actually, this research is, when I applied for this conference, it was an preliminary research of a more advanced paper that we are currently working on, where we introduced more features and we have used more advanced methods, but as it is always in scientific research, preliminary research is always important as well. So the study area is Seville, Spain. And Sevilla, it is located in the southern part of Spain, in Andalusia region. It has a very hot climate, some of the hottest summers in continental Europe. It has the highest heat wave mortality risk of any major Spanish city. Actually, in the news today, there's a heat wave in Spain, as maybe some of you know, and the alert is orange. So it's very alarming statistics and very alarming news. So if we jump to the methodology now, phase 1 is about feature engineering. So we have used Landsat, OpenStreetMap, and QGIS as resources to find the 4 features that we have discussed or talked about. LST, land surface temperature, a vegetation index, NDVI, a compactness, which is a measure of buildings' surface area to volume, which shows how much a building traps heat, and also distance to the nearest park. And this is all done within a machine learning environment. So we have used these 4 features to formulate an index, and this index, it's called Urban Heat Vulnerability Index. It depends on LST as thermal exposure, and the invert of NDVI, because vegetation enhances thermal or mitigates thermal exposure, and compactness of geometry, and also the distance to the nearest park. As I said, this research was developed later, but for this paper on the scale of the conference, we were using only these 4 features. And so we have calculated the index, both as measured true value and also within the prediction in the GNN network PyTorch algorithm. And we have, but if I want to explain graph neural networks quickly, it uses nodes and edges. So the buildings are the nodes, and the edges are the proximity of the building nodes to its neighbors. And why I find graph neural networks interesting in urban planning, because usually we think of the building as something separate, not related to other buildings or its environment. But from a planning perspective, it is important to know that each building affects its neighbor building as well. And there's a certain spillover of characteristics that we cannot, in the Euclidean geometry, translate. But if we use graph neural networks, it does the job for us, which is, I think, advances planning beyond just the fixed and static way we think about architecture and we think about planning in general. So we use the features as well in the nodes. Each node has its own 4 features. And we use the model to PyTorch geometric to predict UHVI as well. So, and then we compare the predicted with the ground truth, and we find the error between the model and the real ground truth calculations. So we have modeled 29, as I said, 29,542 nodes, 301 and 450 edges. And each node, as I said, in this system of graph neural networks, each node, it's like it passes messages to its neighbors. So if a building heats up, it gives its neighbors its heat as well through messaging. And it is only done, this whole prediction is only done through this architecture or this graph neural architecture. So we have trained the model using an Adam optimizer and with the details of the mean square error, and also the evaluation metrics were very high because the mean absolute error was only 2.81 out of 100, which gives us, which means that the predictions were very close to the ground truth calculations. So what are the key findings of this model that we have trained inside PyTorch? it tells us that the primary driver of heat in this area is distance to parks, and the secondary driver is the LST spike, and this is a graphic representation of what we did. So the building nodes are here. We used the building nodes to calculate the different features, and through message passing through the graph neural network architecture, we have calculated our results. So our results that for the features we have used LST, as I said, building compactness, lack of vegetation, distance to parks. And as you can see here, this is the city average of all the nodes in the city or all the buildings. And this is the score for the top 500 vulnerable buildings. And we can see that the feature importance in high-risk zones, after we have normalized the risk factor, gives us these calculations. If we want to see it in spatial distribution, we can see here that the UHVI in Seville is predominantly moderate, but we have vulnerability above in 5% of the building nodes above this 75%, because we have used, as I said, from 0 to 100, the scale. And we can see that high-risk buildings cluster tightly together in specific dense blocks, and they don't spread diffusely across districts, which gives us information about how this neighboring message passing system and how each building affects its neighbor. And also in the top 500, as I said, riskiest buildings, which are in the red zone here, we can see that compactness is the strongest single predictor against the city average, and then land surface temperature, and then the hop distance, which is the distance from this building to the park, the nearest park, and the last one, which is the vegetation index, or the NDVI. What this means in terms of discussion of planning implications, it says that the most compact, hottest clusters, street trees alone give only marginal relief for that. We need to introduce pocket parks for each neighborhood in order for the cooling effect to be more effective. So not single trees, pocket parks. And also this tells us about the methodological contribution of the research, which says that building level graph structurally bypasses the modifiable area unit problem, which means when we use, for example, clusters like neighborhoods or smaller parts even of the census tracts, the building node is more accurate. And the key limitations of the research is the features we used here are purely 2D, but as I said, in the developed version of the paper that we plan to publish soon, hopefully, we have introduced more 3D features that give us more information about the microclimate and the urban setting, and also the building morphology. So with a mean absolute error of only 2.81, a building level GCN maps heat vulnerability across Seville captures spillovers that administrative unit models cannot. As I said, because of the error, as I said, the MAUB, which stands for modifiable areal unit problem, has an error with what affects how buildings talk to each other. But in this model, this is apparently a problem solved. And also the morphology, the geometric morphology of the building is important. As I said, the compactness, which we have used, is an index of the area, surface area of the building to its volume, and with the formula explained before. And it shows us that surface area to volume gives us more articulated geometry, which gives us cooler buildings despite scarce trees. So this, in general, are the general conclusions or of the research.
Wonderful. Thank you, Sonia, for the nice presentation. Very, very interesting.
Thank you.
And it's really interesting. So any question, any comment for Sonia? Okay, I have just few kind of queries, I would say, not questions. Very interesting work, by the way. Congratulations on that.
Thank you.
And Seville is a place where this kind of research is very important to be promoted and also understood how things could be resilient against heat wave, right? And I was wondering, in your research, you had in scope to understand building shade, right? And how one building could be shading others. And that could be one catalyst for building design as well, right? If you have a cluster of buildings, and depending on the sun orientation, you can design the buildings, could be very multi-story buildings, could be low height, either way. They could be catalysts for shades for each other, right? And that would be one factor which could possibly be help to mitigate the heat and also sort of maintain certain living standard. This is number one. Number two, I know Seville is a region which is quite dry in terms of precipitation. That could be perhaps not very promising, but when it comes to wind factors, right? But because let's say after sunlight, wind could be one of the catalysts which might be also flowing through to the building and which might cool off a bit on the temperature, right? And I was wondering if you have a chance to look at those two factors that would possibly help to mitigate the heat waves. Or...
Yes, thank you very much. Actually, as I said, this is a preliminary research to a more advanced paper we are working on right now, and we have introduced, it's called surface roughness, which is how the building from the top looks, not just in 2D. And this gives you, and the height and the volume and the thermal mass, everything about the geometry of the building, which is important for, as you said, the trapping the heat, and also the microclimate, which is how the canyon works and how the vegetation works and everything. In this research for the preliminary part of the research done for the conference, we have just ignored the other factors, really, wind and other factors, just to learn more about this important tool, which is graph neural networks, and how it can evolve the way we think about buildings. Because we are architects, urban planners, we are used to think about buildings as isolated. We design the building to be climatically green, for example, but we don't think about the other building next to us. And this tool, for me, I think will present something significant, which is how buildings, neighboring buildings, can interact with each other and talk to each other and give us other indexes and different results, especially in Seville, because Seville is, as you said, is from the hottest cities in Europe, and I hope this will advance into more better research with what you have just suggested. Thank you.
Absolutely. One last kind of thought, because I know this is a typical kind of problem across the world, not only Europe, not only in Middle East or Asia, everywhere in the world, right? And I was looking at the LINE project back in Saudi Arabia, LINE project, if you know. It's a $1 trillion project where they're trying to infuse sustainability, resiliency into the whole city planning process. And I was wondering if you had a chance to look at that practice, how they're planning and visioning the LINE project itself, in terms of mitigating heat and tackling those possible disasters, if that could be any help to your research. Or...
Yes, I have seen the initial plans and concept of the LINE, and I think it's an ambitious project, giving the vision and everything. And but I haven't really studied it in terms of heat. Of course, it will be a big problem for heat trapping and heat mitigation and cooling and everything to do with urban climate and climate change and etc., especially in the setting of Saudi Arabia, and not just the LINE, every other project they use in an urban planning project, including open area bridges, open area walking lanes. They have introduced many concepts that I hope that they are studying in terms of climate change and urban heat islands and urban heat mitigation. Definitely, if there are studies that have studied that, I would be interested to look at.
Absolutely. Thank you very much for the nice presentation. Very intriguing. Wish you all the best, Sonia.
Okay. Thank you. Thank you.
Great. I think this presentation, with this presentation, we are almost at the end of this session. And just to wrap up, thank you everyone for your wholehearted participation and your sharing the knowledge, working with on your papers and research. It's really intriguing. It is very dense, to be honest. The knowledge we have shared today is very dense, very fruitful, and very resilient that we can use for our upcoming futures. So I wish you all the best for your endeavors and wish you good luck on your life as well. With that, I would conclude my session here. Thank you very much.
Thank you. Bye.
Thank you all.
Thank
Good
you.
evening.
Thank you.
Thank you so much. Bye.
Thank you.